Right, so this is an additional video on the topics of composite functions, and I'm just going to do two examples from the book. And this first example says if f of x is equal to square root x, and if g of x is equal to square root 2 minus x, find f of g, g of f, and g of g. Alright, so the first two look easy because they look familiar. So this is the same as f of g of x. So we just write g of x, and then for every instance of x in f, we write that. So I'm just going to start with f of x because it's on the outside and it's kind of easier to do. And this is g of x. 2 minus. I'll do it in a different color so you can easily distinguish between the two. Okay. So that's g of x. That does not look good. And the cyan one on the outside is f of x. Okay? And because it's square root of a square root, you could think of this, you could think of square root. Square root's really just square root x is the same thing as x to the 1/2. Okay? So you could think of this as being equivalent to, I'll do it in the same color. Here's f of x on the outside. So let me get rid of this so it doesn't confuse you. Okay, f of x is on the outside, that's 1/2, and g of x is on the inside. And that is 2 minus x to the 1/2. Okay, and an exponent to an exponent is that exponent times this exponent. So 1/2 times 1/2 is equal to, and I'll just write a new one, 1/4, which is the same as the 4th root of 2 minus x. And that is the answer the book gives. Trust me, I checked. Alright, so g of f of x is simply, I'm sorry, that was a whatever. Okay, so that's, if you write it like this, that's this, g of f of x. And so we're going to write, let's write g of x first. I usually write the outside ones. I don't know why, even though you're supposed to write the inside ones. So f of or g of x is root 2 minus, and f of x I did brown, so root x. And that's the composite. And there's nothing else you can do to that, so yeah, that's the answer. Alright, f of f, c. We'll do the outside f, I'll distinguish between these two, and the inside f in yellow. So this is equal to, since f of x is square root x, this is just square root x, which is the same as we learned before, 4th root x. Simple as that. And g of x is g outside g of x, which is the same as root 2 minus x. Yeah, so root 2 minus, and then root 2 minus x. My roots are getting really sloppy. There we go. And you could just, you don't have to have the parentheses here separating it. If you're writing it all formally, like that. And that is the answer. And these are all the right answers. So now I'm going to move, that was example 1 in this part of section 1.3. Now for example 2. And example 2 really just demonstrates the fact that you can have a composite function of more than two functions. So for example, you can have f of g of h. All right, and equivalently, that is f of g of h of x. And I like to write my parentheses with sizes because it just makes things easier, recognizing quantities and whatnot. So for example, the example here says if f of x, oh this one's a doozy, if f of x is equal to x over x plus 1, whew, and if g of x is equal to, what does it say, x to the 10th, and if is brown a good color? No, I don't think so. White, I haven't used white in a while. If h of x is equal to x plus 3. Okay, and they are asking for this, f of g of h of x. So, I'm just gonna write the inside first because this is a biggie. Well, actually, let's see. Yeah, I can do that. Well, actually, I'm gonna have two instances of g of h of x here. So g of h of x here, g of h of x here. I'm actually gonna write the separating bar first, and then I want work my way in. So g of x on top to the 10th, and then there's going to be one down here, and then this is still f of x, so plus 1, and h goes in the middle of g of x, so it's just x plus 3, x plus 3. And that's it. That's the answer. So x plus, that quantity x plus 3 to the 10th over quantity x plus 3 to the 10th plus 1. And that would be f of g of h of x. That's a lot.